Hey, what's up, guys? This is Sheng here. So today, let's take a look at today's daily challenge problem, number 41. It's a very early problem. First, missing positive. Okay, so the description is very straightforward. Basically, you're given like an unsorted integer array. Find the smallest missing positive integer. For example, this one, right? So I mean, the first missing positive integer is 3 here, and this one is 2, and this one is 1. Okay. Let's just forget about the follow-up here. So what's going to be the most naive solution, right? I mean, the most naive solution will be we just we need to sort it. Not sorry, we don't need to sort it. I mean, one of the things is that we just need to try from 1 to n. Basically, the length of n of the number is n. The length of the number. We just need to get the length of the numbers here, and then we just need to uh try n times. So why is that? Because if from let's say we have 4 numbers here, so the worst case scenario is this is 1, 2, 3, 4, right? So that's the worst case scenario, which means that everything is everything from 1 to 4 is here. So the first missing number will be 5 in this case. Otherwise, as long as there's anything that missing here, we just need to loop through these 4 numbers, and then we'll definitely find that. Okay. So to do that, I mean, it's very simple, right? So we just need to convert. First, we convert the numbers to a set. Okay. Now we have a set here. So and we have an n here, length of the numbers. So all we need to do is we just need to do a I in range of n here, of n n plus 1, I think. Yeah, we can do this 1. Yeah, 1 to n plus 1, right? So I mean, if the I is not in the num set, as long if I is not there, we simply return I, right? Otherwise, otherwise is this case. Basically, everything from 1 to n plus 1 is in here. So which means the the n plus 1 will be our answer, which in this case is 5, right? So that's that. I think this should just work. I'll just submit it. Yeah. So pretty straightforward, right? I mean, so the time complexity for this one is like it's O of n, right? So and here is also O of n. So the time complexity is O of n, and the space complexity is also O of n because we're maintaining a set here, and here is like O1, right? Okay, and then the follow-up. So we have O1 already, but can we use constant extra space here? I think this is what makes this problem a little bit tricky because to be able to utilizing like to be able to make it like a constant extra space, uh, we have to somehow use the original numbers field here, original numbers list here, so that we can do some markings on that. Okay. Mm, and the way we're doing it is that is the we'll be using the since we don't want to like miss the numbers, we don't want to lose the number itself. So one of the technique we can use here is we can revert this number. Basically, we revert this number from positive to a negative. So whenever there's a negative number, we know that okay, that number has already seen before. So basically, we're using this index to represent that number. So that I mean, so the first for loop, right? The first for loop is that will be basically okay. Let me try to write this thing here. So the first for loop, I mean, uh, we'll remove the invalid numbers. So what are the numbers that is invalid? First one is the ones that's the it's smaller than 0. Okay, that's definitely an invalid number. And how about the others, like the numbers that's greater than the length of n here, because we know the missing numbers has to be between the 1 and n here. That's our missing number range here. So for anything that's outside of this range, we can simply invalidate them. So we do this. So I in enumerate nums. Okay. So if the num is equal smaller than 0, okay. If it's 0, or the number is greater than n, so we just mark them to a we just mark them to a like a very huge number, like nums, like the we don't want to mark them to a negative numbers, because we'll be using negative number later on. So so the easiest way we just mark it to a n plus 1. Okay, basically anything which is greater than n later on will be treated as an invalid number. So now the second loop is we just need to put and okay, and the numbers here, right? So we're going to convert this number to its absolute value. Why is that? Because when we are marking processing the card numbers, those numbers could have already been converted to its negative version. That's why to be able to get the index, we need to convert it to its absolute value. And then we only do this whenever this thing is within the n, right? Because we know that our range is in the numbers we need is from 1 to n. If anything that's greater than n here, we'll simply ignore it. Now we have index here, right? So the index is like this because the number is 1 based and our index is 0 based. So, and what we're doing here is basically if the numbers dot index, if the current index, the number of current index is pointing at is greater than 0, we convert it to a negative value. Okay. So why we're checking this? Because this is just to avoid like double double reversing here, because if it is a negative number and we're doing this one more time, and the negative number will become a positive number, which will be losing the purpose of marking it to a negative. Okay, so now after the second for loop here, as long as the values on this current index is a negative value, then we know, okay, we have seen this number. Okay, and so that we just need to do this in range. So now we just need to loop through this one last time. Basically, if the nums in the I here, right, is equal or greater than 0, okay, then we know, okay, fine. Uh, uh, 0. Okay, I think we don't need equal here because for zeros we have already converted to n plus 1 here. We just need to return the I plus 1 here. In the end, same thing here. If none of those works, then we return n plus 1. Okay, submit. Yeah. So, this problem, as you guys can see, so now basically we have a 3 for loop here, n plus n and plus n. So 3n, still O of n. Okay, and the space complexity is 1 because we're not introducing any of the new list here. We're basically we're utilizing this technique here. I think for this problem, I think this is the technique you might want to master, right? Or understand. Basically, uh, we uh, we mark this number to its negative versions to mark this something to flag this number while we're still keeping this value of this number. That's one of the technique. When it comes to marking the numbers in the array. Yeah, and other than that, it's pretty straightforward, right? I think there's a few like corner cases you might be careful. be careful of. But other than that, for example, how can you handle the zero case here, right? I mean, in our case, right, because we're treating zero as an invalid number. That's why we are marking everything, including zero, uh, be smaller or equal to zero to an invalid number. Also the other side. Cool. Yeah, I think that's it for this problem. Yeah, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.